broaden this to just the instantaneous rate of change in general. So we don't have a velocity function at this moment. We just have a general function, f of x. This is example number 1 on your worksheet. Okay. And after we do this one, I'd like you to try example number 2 and example number 3 on your own. We have this function f. All right. When x is 3, f is 8. When x is 4, f is 10, so on and so forth. Okay. We're interested in approximating, not finding, but approximating the instantaneous rate of change of this function when x is equal to 4. Okay. How is this function changing when x is equal to 4? So the answer is not 10. We're not asking for f of 4. Yes, f of 4 is 10, but we don't want f of 4. We want the rate that the function is changing. And we have to do what we did with the velocity function in the previous video. Since we don't know exactly how the function is changing at x equals 4, we have to do an average rate of change using data immediately before and or data immediately after x equals 4. Okay, because we're interested in basically looking at that secant line that we had there and finding that slope. All right, we could plot these points. We don't have to, but we could plot these points. Okay, over 3 up 8. Right, that puts us there. Over 4 up 10. That puts us there. Over 5 up 11. That puts us there. We're interested in trying to find the slope of that line there that would connect, or the curve that would connect those points. That's the instantaneous rate of change. We're interested in that slope value. That's why we're using the average rate of change, because we know the average rate of change is the slope of the line that connects our 2 points. Okay, so we have a choice here. We can use the points for 3 and 4. We can use the points 4 and 5. It doesn't matter. They're both correct answers in this case because both of them involve the 4 and the 3 is immediately below, the 5 is immediately above. So either one of our answers would be acceptable. I'll do them both, but we only have to do one here. Okay. So if we were to try looking at the slope as, which is in essence the way the function is changing from x equals 3 to x equals 4, then what we're looking at here is f of 4 minus f of 3 over 4 minus 3. Okay, that's going to get us our answer. F of 4 is 10. F of 3 is 8. So by substitution, we have 10 minus 8 over 4 minus 3. So one of our possibilities is 2. Okay, that's not the only approximation, but it's one, and it's a good one. As I mentioned, we could also go from 4 to 5. Okay, that's also legitimate. The 4 could be the ending value of our interval, like it was here, or the 4 could be the starting value of our interval, like it would be with this next possibility here. So what we're looking at now is f of 5 minus f of 4 over 5 minus 4. And again, you don't need to do both of these. You only need to do one. Okay, both answers are going to be fine. Just showing you both so you can see that they're both legitimate. So f of 5 is 11. F of 4 is 10. So we'll have 11 minus 10 over 5 minus 4. And we can see that this simplifies to 1. Now, one answer is obviously not the same as the other. That's okay, because ultimately we're looking to approximate the instantaneous rate of change. Okay, so because it's an approximation, either one of our answers is completely acceptable. You don't have to write them both. You only have to write one, and both are correct, even though they're different, because it's an approximation. So now you've seen this one, give example 2 and 3 a shot, please.